All right, this is another example, and this one's going to be a little bit trickier because there's a horizontal shift on the graph. So we start the same way. We're going to subtract 3 on both sides. So 1.16 minus 3 is negative 1.84. Then I'm going to divide by negative 2. So now I have 0.92 is equal to sine of theta plus 3 pi over 2. We're going to do the inverse sine of both sides. And that's going to equal theta plus 3 pi over 2. So the inverse sine of 0.92 is 1.168 equals theta plus 3 pi over 2 and the other angle theta equals theta plus 3 pi over 2. So this is a quadrant, let's see, we're doing sine. That's a quadrant 1 angle, 1.1. Pi divided by 2 is 1.57. So this is my quadrant 1 angle. I need to figure out what my quadrant 2 angle is. Okay, before I do that, I'm just going to go ahead and finish it. I'm going to subtract 3 pi over 2. So theta equals 1.168, that with all the decimals, minus 3 pi divided by 2. And I get negative 3.544, which is not in my range or in my 0 to 2 pi. So add 2 pi to it to get a coterminal, plus 2 pi. So 2.739. All right, we'll check that maybe at the end. All right, if I go back to where I was at the beginning here, we got 1.168. So I need a quadrant 2, 1.168. So I need to figure out what is this amount in green. So again, I look at it, I know that the entire line over to pi is 180 or pi radians. So pi minus 1.168 is going to give me that value. Pi minus, find my exact 1.168, is 1.974. So that goes here. 1.974 is my quadrant 2 angle. Then I will subtract 3 pi over 2 from that. Get negative 2.739. Add 2 pi to get it into the 0 to 2 pi area. And I get 3.544. So the two angles that are between 0 and 2 pi that make the equation true are these two. And I'm going to copy the equation, put it down here, and just kind of remind you that what you're saying is if you do 3 minus 2 sine 2.739 plus 3 pi over 2, that should equal 1.16. And the same thing, you could plug in 3.544. And you want to use the exact value, not the rounded decimal. So again, a couple steps. I isolated the trig expression. I evaluated the inverse. When I evaluated the inverse, that gave me, in this case, it gave me a quadrant 1 angle. So I said 1.168 equals theta plus 3 pi over 2. Subtracted the 3 pi over 2 to actually get theta. But then if I tell you I want the answer between 0 and 2 pi, you need a coterminal angle. So 3.544 as a negative angle plus 2 pi gives you a coterminal. Then I said, what about the quadrant 2 angle? Because sine is positive in quadrants 1 and 2. So I use the idea of a reference angle. If it's 1.168 inside quadrant 1, I need a 1.168 reference angle inside quadrant 2. That's what's drawn in red. To get the actual angle that's not the reference angle, I needed to do pi minus 1.168. And then use that value to solve the rest of the equation.